Hello everyone, welcome back to lecture. We're going to continue along our study of section of chapter R, which is the review chapter. This is section 5. So this time we're going to focus on equation with radicals. So what we're going to be looking for is something that looks like the square root of something, the variables underneath the radical, and this is 2. Here's the radical. Okay, and we have some index, and this could be the cubed root for 3, 4th, 5th root of x. If there's nothing there, understood 2. Okay, so in this case, this is 2. So I want to look at solving equations. So this makes it an equation when I got it equal, and I'm looking for things underneath where the variable is underneath the radical or inside the radical. Okay, so basically all I want to do is take this just like I had before. If I had x squared is equal to 4, I took the square root of both sides, plus and minus. So I had that as a solution. Here I want to do somewhat the opposite. I'm going to take and square both sides, just like that. And then that gets rid of this radical. This needs to be the same index number as understood here. So x would be equal to 4. And then I'm just going to check, does the square root of 4 equal to 2? And that gives it to me. Okay. So here's my slides. Let me go over here. This is what we're talking about, solving radical equations. Get back. Okay. So I want to do the very same thing no matter what that index is. And in this case, I've got as an example, the cubed root of x is going to be equal to 5. And what I want to do is basically just have nothing left but x here. So I want to get rid of all that radical stuff. And in this case, that radical is 3. That index is 3 on the radical. So I'm going to raise this to that same power, 3. And then that gets rid of the radical. And then 5 times 5, 25 times 5 would give me the 125. Okay, and then I would check it. Does the cubed root of 125 equal to 5? And that would check. Okay. So there is one problem that I had that I can run into, and it's based on this. If I start out with unequal, so this is not equal to, right? So I want to say, I'm going to erase this. This is not equal to that. But if I square both sides, I get equals. So I can start out with numbers that are not equal, and if I square these things, I end up with something that's equal. And I have to worry about this generating extraneous solutions. So basically, this is the problem of extraneous solutions. Okay. And our book gives us something that looks like this. I want to look at the square root of x is equal to -10. So we know that the square root, once I do the square root, this can't be equal to -10, right? Okay. So what I want to do though, if I square both sides, I get x is equal to plus 100. Okay, and if I check, the square root of 100 does not equal to -10. Okay, I'm only talking about the principle. You know, this could be -10 times -10 would be plus 100, but that's still not the square root. I mean, that's not what we're concerned with. We're just doing the principal square root. Okay, so that's the concept of extraneous solutions. And here the solution set is just basically the null. There is nothing. Okay, the null set. Okay. So here's the rules for solving a radical equation. Isolate the radical. If it has more than one radical, I'm going to pick one, square both sides, pick out or raise it to that index, and then do the very same thing again. Okay. And then I'm going to check the potential solutions. Okay. So let's look at a basic one. So if I wanted to solve x plus 10 minus 4 is equal to x. Okay. I have to kind of look and see, you know, what am I doing? Is this a linear equation? Is it a quadratic? What am I doing? I've got something with radicals here. And I just have to recognize the technique of getting this isolated and then squaring both sides. Okay. So I want this all by itself on one side, which means this needs to go over on the other side. And how do I do this? I'm just going to go plus 4 plus 4. Okay. That's going to get rid of that. So square root of x plus 10 is equal to x plus 4. There's my radical all by itself. So what I want to do basically is go from there and just square both sides. Okay. This gets rid of the radical, x plus 10. Now that's what I wanted here. But now I've got this, you know, binomial here raised to this power, so I'm going to square the first. This is x plus 4 times x plus 4. Do my, you know, distribute, square the first, multiply the two together, 4x doubled is 8x, and then square the second. And that's the quick method of going through and generating this x plus 4 squared. Okay. Quadratic, I need to isolate this all by itself and get it equal to 0, which means this needs to be 0. And the way I do that is do the opposite, minus x minus 10 to both sides. And then I group x squared plus 7x with my 8x and my minus x. And then 16 minus 10 is plus 6. And then I go through and factor. I try factor first. Can I get two products, two factors of 6 that add, that says add, to the 7, and yeah, 6 and 1. 2 and 3 wouldn't work. X plus 6, x plus 1. And then I set each factor equal to 0, that 0 property. The only way I get two things multiplied and give me 0 is when one or the other is 0. So x plus 6 is equal to 0 when minus 6 minus 6. Or x plus 1 is equal to 0 when minus 1 minus 1, when x is equal to negative 1. Okay. So I have my two potential, these are my potential solutions. Let's go back and check them for extraneous solutions or just something that I did wrong in here. Square root, I'm going to use the x equal to negative 6. I get, that's for my first term, minus 4. Does that equal to my negative 6? Square root of 4 minus 4 does not, this is 2 minus 4, which is negative 2, so that doesn't work. Now let's go with the x equal to negative 1. Does that equal to negative 1? So negative 1 plus 10, that gives me the 9. Square root of 9 is 3. 3 minus 4 does equal to negative 1. So there's our solution, is just that one. Okay, so here's another one. And this involves a radical with our two separate radicals under here. And we're going to see. Now, if they were the same thing, we could kind of combine them and then go through. So if I had like m minus 1 plus 4 square root of m minus 1, we could combine them. But here, underneath, the radical is different, so we can't combine them directly. 3m plus 1 is equal to negative 2. Okay. So I want to pick one of these things, isolate it, do our little, you know, take the index, raise both sides to that, and go from here. So I'm going to pick this, I'm going to leave this one alone, get this over here. So plus square root of 3, you know, I'm going to do this. Just like that. Okay, let me bring this down for you. So I'm going to do both sides to get rid of that. Okay, so that's what I'm left with. I'm only focusing on here because I'm going to get rid of this radical. That gets rid of that, and I'm going to move this over here. That's this piece, and then I want to focus on this. Okay, I'm going to do the very same thing I did just a second ago. I'm going to square this out. Square the first, multiply the two together and double, which is times 2, and then square this first. So this was going to be, that squared gets rid of that. So I'm just going to write this as 3m plus 1 in parentheses. I'll be able to drop that in just a second. This times this is negative 2 times that radical doubled is minus 4. And then square the last, which is plus 4. Negative 2 squared is plus 4. Okay? And then I want to get this all by itself. Okay? So I'm going to get this, I'm going to move this over here and this over here and then group. So minus 3m plus 1 and minus 4 from both sides. So m minus 1 minus 3m plus 1 minus 4. That goes out, that goes out. Okay, and then this is equal to negative 4 square root of 3m plus 1. Okay, so let's combine this in group. Okay, m minus 1, but let's just leave this for a second, minus 3m minus 1 minus 4 minus 2m minus 5 minus 6. Okay. Now see that I can kind of, let's do this. This is going to save us a step now. Sometimes I would just divide both sides by the negative 4, all of this, and then square. But I'm going to leave this like it is, but I'm going to take out a negative 2. I'm going to divide both sides by negative 2 to kind of simplify things. This would be m plus 3. And that's just so I can, and that kind of takes some foresight to know what I'm doing here. Why not divide both sides by negative 4? We could do that, but then we'd have something in the denominator when I squared, and it would come back to this. So here, I've got it to this point, I'm going to square both sides. M squared plus square the first, multiply the 2 together and double, that's 6m, square the last. That's our quick way to get this expanded. And then this is just this squared times this squared. So is equal to 4, 3m plus 1. $12m plus 4. Okay. So at this time, I'm kind of, before I start doing anything else, what am I dealing with here? I've got rid of all my radicals. Well, this tells me I've got a quadratic, and a quadratic I have to be equal to 0. So this, everything has to be over on one side. Okay, and I'm going to do this by subtracting this all from both sides. So m squared plus 6m plus 9 minus my 12m minus my 4 is going to be equal to 0. M squared minus 6m plus 5 is equal to 0. That's my standard form quadratic, and I handle that by factoring, try to factor first, and then I go to quadratic, complete the square quadratic formula, and I would just go to the quadratic formula if I was, but I can factor 2 factors of 5 that add to 6. That's obviously the 5 and the 1, same sign. That sign is negative. Okay. So from this factor, x is equal to 5, x equal to 1 when I set each one of those factors equal to 0. Okay. And if we check both of these things, both of them would work, and we would get 5 and 1 as our solution set. How do I know? I would have to go all the way back up. 5 minus 1, that's 4, minus 15 plus 1 is 16. So that's 2 minus the square root of 16 is 4. 2 minus 4 gives me the negative 2. And then the 1, this would be 0 minus 3 times 1, 3 plus 1 is 4. That would be negative 2 is equal to negative 2. So both of those would check. Okay. What about if there's some, if we've got a rational exponent? What's a rational exponent? So if I have something that has let me show you what rational exponents is here. So if I have this is really x to the 3 halves, or both of these are equivalent ways of writing the very same thing. This is the rational exponent. This is the rational exponent version of that, and I can go back and forth. And this could actually be written this way as well. It turns out that this is the very same thing as that. I can cube x and then take the square root, or take the square root and cube, and I get the very same number. And I can represent both of those by that rational exponents there. Okay. So if I come across a rational exponent, let me go back here, bring us down over here a little bit. Let's take a look at this. 2 to the x plus 1, 2/3 is equal to 8. Now I can simplify a little bit just by dividing by 2, because this exponent only goes with this. Does not go with everything, or everything would be in the parentheses. So I'm going to divide out both sides like that. Okay. X plus 1 to the 2/3 is equal to 4. So this is kind of the standard form for doing what I'm about to do. Whatever this rational exponent is, I'm going to invert it and then raise both sides to that power. So here I'm going to do another exponent, 2/3. I'm going to invert this and raise to that power. So this, when I multiply my exponents here, this is just going to be, if I cancel, this is just 1. And then 4, I have to do both sides, so I'm raising both sides to the 3/2. Okay. So x plus 1. Now here I could cube and take the square root, or take the square root and then do the cube. So I'm going to look at doing this first to keep from getting such a big number, and then try to take the square root. So I'm going to go take the square root and then cube it. I'm taking the square root and then do the cube. 2 cubed is 8, so x plus 1 gives us the 8, and then I just solve because it's a linear equation. X is on one side, constants on the other. X is equal to 7. And then if I check, does 2 times 7 plus 1 to the 2/3, does that equal to 8? 8, cubed root of 8, that's 2 times 2 times 2, and then I square it, so this is 2 times 4, and that's equal to 8. So this is kind of our quick check. Okay. And let's push this up a little bit, like that. Now here what I did was correct, okay? However, when I did this piece of it, I have to be careful in that when I take the square root, you remember I need to do plus or minus this version, okay? So here, when I do the square root of this, this could be, so this needs to be negative. When I do the square root plus or minus, plus or minus 2 cubed. I had to be careful there. And this is plus or minus 8. So plus or minus 2 cubed, I've got my plus and minus 8, and then plus or minus 8. So here I need to expand out a little bit. Either x plus 1 is equal to 8 or x plus 1 is equal to negative 8. Okay, so x is equal to 7 minus 1, or x is equal to negative 9. So we got one of these things out of there, the 7, but by not remembering that this is a square root, we missed this particular solution. And let's see if this works. So if I go back again, 2 times negative 9 plus 1, the cubed root, and does this equal to 8? 2 times negative 8. This is take the cubed root and then square it. The cubed root of negative 8 is negative 2. That's 2 cubed. So this is 2 times 4 again, and that's equal to 8. So my solution set should have been to both of those. Okay, or negative 9. So okay. So that's basically what we're the radicals, simplified radicals for equations, solving the equations, and we'll continue next time with other things. So we'll see you next time.